There it is. So, without a calculator, sketch the graph of each of these exponential functions. Identify the y-intercept, the horizontal axis for the graph. Use the table to help make your sketch. Let's do that. So our first function is f of x equals 2 to the x power. So right off the start, do we know if it's going to be a growth or do we know if it's going to be a decay? Well, actually, before I'm going to pause my original question and I'm going to let you answer. Okay? I'm going to ask three questions to my question. What kind of function is this? Why? Because the exponent is where the variable lives. Yes, okay? So this is an exponential function, okay? Which means it's either going to have exponential growth or exponential decay. So now, back to my original question. Is it growth or decay? Why growth? You were correct. What about actual one? That's actually horizontal. Because any one to any power is one, right? So it's always going to be one all the way across. Yeah. Okay. So we're thinking. So let me go a little side action over here as my wrist is going. Y equals A times B to the x power is an exponential. Okay? And that B is going to determine our growth or decay is going to be determined off of that B value. Okay? So our preliminary guess, which really isn't a guess, it's a very good, logically explained reason, says that this is going to be a growth. Right? Which means then a growth would look like this, and a decay would look like that. Okay? Growth, as you're going to the right, as you're getting bigger and bigger numbers, it's going to go up. Decay is going to be small. Okay? So let's fill in our chart. 2 to the negative 2 power. What do we got? Without a calculator. 1/4. Two to the negative 1 power. 1/2. 2 to the 0 power. 1. Anything to the 0 power is 1. 2 to the 1st power. 2 to the 2nd power. Smooth curve, exponential growth, confirmed. An exponential growth. What do we have for an intercept, a y-intercept for this particular one? The y-intercept. Huh? TC? 0, comma 1, yes. In point form, because the y-intercept is a point, it would be 0, comma 1. Yep. Love it. Horizontal asymptote. Okay, so we got the HA here now. And remember, horizontal asymptote is a line that our function approaches at one of the infinities, at either positive infinity or negative infinity. So my question to you is, will this function, this maroon function, will it ever be negative? Is there any power that I can throw onto 2 to give me a negative number? No, because 2 is always going to be positive. So it's always going to be positive. So therefore, we have a horizontal, whoa, where did that go? We have a horizontal asymptote at y equals 0. Love it. And we've also graphically confirmed that we are equal, because our function as we go to the right is getting farther and farther away from the horizontal axis. That's the true Bose definition. The street definition is the farther we go to the right, the bigger it gets. But at this time, what I would like you to do is I would like you to do let's do them one at a time. Let's do number 2 first, and then we'll do number 3. What are we thinking? Growth or decay? Decay, okay. Right. So we got a decay here this time. So let's put in a couple of points. So we got 2/3 to the negative 2 power should be 9/4. 9/4 will go up there. 2/3 to the negative 1 power should be 3/2. 2/3 to the 0 power should be 1. 2/3 to the first power should be 2/3. 2/3 squared should be 4 ninths. Kind of is, but that's okay. I'm over it. Y-intercept, 0, comma 1 again. Love it. Horizontal asymptote, y equals 0 again. Love it. And draw it. Well, all right. Did you guys get enough time to do number 3? Yeah. Okay. Do number 3. All right. So now it said go. So now, okay. So growth or decay right off the start?
Growth.
Growth. Why growth?
Because it's more than 1.
Yep. 5 divided by 2 is 2.5. That's bigger than 1, so that means it's going to be a growth. So we know that it's going to go up and to the right. Okay? All right. Let's plug some points in and see what we got. -2. If I plug -2 in there, I got 5/2 to the -2 power is 4/25. 4/25 minus 1 is -21/25. What? Agree with me on that? Speak now or forever hold your peace. Okay. -1 power. 5/2 to the -1 power is 2/5. 2/5 minus 1 is -3/5. 0. 5 halves to the 0 power is 1, minus 1 is 0. One. 5 halves to the first power is 5 halves. Minus 1 is 3 halves. Two. 5 halves squared is 25 fourths. Minus 1 is 21 fourths. What is my y-intercept? The origin, yep, 0, 0. What is my horizontal asymptote? Y equals negative 1. Love it. Good times. So some thoughts. In Algebra 2 last year, you were able to identify exponential growth or decay based on the value of b. Again, let me bring back in y. Whoa, hey now. Let me bring back in. Sure. Easy for me to bring back in. Let me bring back in y. Why? What? Sometimes it's hard work to just find its own. Okay. So based on the b value, okay? So based on the b value, we said that if b is greater than 1, we are growing. If b is now, I would actually take that one step further on those two. Okay? I would actually take this to be, I would go here, and I would go if the absolute value of b is greater than 1, because we can have a negative 2 value for b, okay? And that would be, actually wait, cat breaks, no, because we can't have a negative, that's going to flip-flop. Nope, it's got to be positive. I got ahead of myself. Let's restart. So b has to be greater than 0. So then here we can say, oh, that's what we can say. We can say here that b is greater than 1 and 0 is greater than b is less than 1. I like that. I like that. Because then that becomes that. When we graph exponential functions, we are only going to graph 2 key points. But just so you know, because we know this little trick with b, and we know that b is greater than 1, okay, that's going to grow. B is less than 1, okay, that's going to decay. And we know that. We only really have to graph 2 points. Okay? And the 2 points are the 2 easy points. Okay? It's the 2 points when my exponent equals 0 and when my exponent equals 1. If you go back to the front side of that note sheet, okay, so the 2 easy ones here are when my exponent is 0. Because what happens? Anything to the 0 power becomes 1. Okay? So that one makes that one easier. Makes this one even easier because it's just 1. Makes this one even easier because it's just 1. Okay? So, and then the other easy one is when it's equal to 1. When my exponent is equal to 1, because then that gets me to that point where it's it's just the base. Okay? And we're just going to be sketching that out. Okay? For graphs in the form f of x equals a times b to the x, the y-intercept of the graph is located at the point 0, because all y-intercepts are at the point 0, comma something. What do you think it's going to be? 0, comma what? What do you got? 0, comma 1? Do we agree with 0, comma 1? Well, let's put 0 in this function right there. If I put 0 into that function, b to the 0 power is 1 times a. So my y-intercept would be 0, comma a in this function, if we had an a value. Now, in all of the functions that we did on that front side of the page, we didn't have any a values. Okay? So that's why I can see why you said 0, comma 1. Right? And this also doesn't take into like that last one we did where we subtracted a number. We subtracted a c value. And the horizontal asymptote is the line y equals 0. For graphs of the form f of x equals a times b to the x minus c then plus d power, okay? Because that's got all of your, so what that encompasses is, that encompasses some horizontal shifting, and that encompasses some vertical shifting. C is going to be the horizontal shift. D is going to be the vertical shift. That's going to shift it up and down. So we can't, the only thing that we can really say here for a certainty is what the horizontal asymptote is in this one. Because we can't say, if I plug 0 in for x, I can't, it's not going to be a certain. So the only certain one is y equals d is the horizontal asymptote. That's the only certain. After that, again, what you're going to want to do is you're going to want to make that exponent be 0 and make that exponent be 1. Okay? So, with that being said, what I'd like you to do now is, I would actually like you to do number 3 at this time. Graph me number 3. My first question to you is growth or decay? Growth, because our b value is bigger than 1. Okay? My second question to you is, what is our horizontal asymptote? Y equals -7. Okay. So y equals -7 is my horizontal asymptote. Okay. Next question, what x value will make my exponent be 0? What? -2? Okay. So that's going to be the first x value that I try. -2. If I plug in -2, -2 plus 2 is 0, that's what I wanted. 3 to the 0 power is 1. 1 minus 7 is -6. So we are 2 over, and we are way down, maybe a little higher. Okay. What is the x or value? Yes, what is the x value that will give me an exponent of +1? -1. That's going to be the next one I try then. -1 plus 2 is +1. 3 to the first power is 3. 3 minus 7 is -4. Now, if you want, you can complete the graph. The only other one that I would possibly put in there is I would just put in where we are at 0. 0 plus 2 is 2. 3 squared is 9. 9 minus 7 is 2. But that y-intercept one, not necessary to put in. But it also helps. Okay? Love it? Awesome sauce. We will pick up on this stuff again tomorrow. I would like you, however, tonight to finish off the other 3 problems in that. Right? Is it just 3? The other 3 problems on that page. Okay? All right. So just please grab those. We'll quickly go over them tomorrow at the beginning of the class.